So the DAC can be controlled using the tone class. So the tone class is actually a class I've written and developed. So this is not part of the Mbed API. This is a custom class that I've developed. So when you create a tone object, we create it using the constructor like we do the official Mbed API, and we specify a pin to use. So the pin must have a DAC peripheral. So on the Mbed NXP LPC 1768 board, we can only use pin 18. So that's the only pin that's got a DAC. So in this example here, because now this is a separate class, so I have to include the header file for that class. So here include tone.h. So this is the name of the class, and I've created an object called DAC connected to pin 18. So before you use the object, you need to initialize it. So the first thing you need to do is dac.init, call the init method. So this creates a sine wave lookup table with 16 samples that we saw before. And then we can use a play method that can be used to play the set frequency for a particular duration. So in this example here, so when you do the first argument in the play method is the frequency f. So this is now inside of a for loop that's gone from 100 up to 1000 in the increments of 100. So this is going to play a tone of 100 Hertz for 0.2 seconds. Then it'll do 200 for 0.2 seconds, 300, 400, 500, up to 1 kilohertz. So there's note here, I've got this the duration is 0.2, so just need to put a wait after it, or it's just a bit longer, so it can play that tone, and then you'll do a delay while it's playing that tone, and then it'll play the next one. So basically, the play method, you pass in a frequency and a duration, and the DAC will output a sine wave with that frequency and that duration. So if you apply that sine wave to a speaker, you'll be able to hear the audio tone. So it's also possible to play melodies by creating an array of the notes and an array of the note durations. So the arrays use the const keyword to store them in flash and save up space in RAM. So the tone library contains definitions of note frequencies to make it easier to construct the melodies. And the melodies can be played at different tempos set by the beats per minute, and can also be instructed to repeat. So it's very simple to play melodies. Again, we've got the same, we included the header file, created this object, but now I've created two arrays. So one is this note array. So that contains the notes. So you can find in the tone.h header file, you'll find all the note definitions, so the actual frequencies, what correspond to the different notes, are defined in the tone.h. It's just easier to make this note array using like E7, C7, whatever, rather than the actual hertz, the actual frequency of that note. So as well, and you can see that zeros here just correspond to a blank, so that leaves a gap in the melody. And then the duration array, so in this example, 8 corresponds to 1/8 of a note. So you can see in the array, so this first value obviously corresponds to this, that will correspond to this one, and so on. So they need to have the same number of elements in the note array and the duration array. So then in the main, you have to initialize the DAC again, and then we need to calculate the number of notes in the array. So this sizeof command tells us the number of bytes that make up, so here note array, so size of note array will tell us how many bytes this array takes up, and then if we divide it by the size of an integer, that'll give us the number of notes in this array. So now we know the number of notes in an array, so we can use a play melody method. So with a play melody method, you have to pass in several arguments. So n, the first one, is a number of notes. The second one is a note array, the duration array, the BPM, beats per minute, and then whether we want it to repeat. So that could be true or false. So you can get it, if you put false, it'll just play once. If you put true, it'll just keep. And this just does it in the background, so you can put more chord after here and the melody will just continue playing in the background.